Lecture 6.3, Day 2, Integrating Natural Log and Arcsine. We use integration by parts when the integrand can be written as the product of two functions, u and dv. Actually, any integral can be considered as a product, and in a few cases, this allows us to use integration by parts to find an integration formula. Our first example is the integral of natural log of x dx. We can think of this as the product of 1 and ln x dx. Starting with the integral of 1 times ln x dx, we use the acronym LIPIT to choose u. We notice a logarithmic factor, and logarithmic factors come before polynomial factors, and 1 is a simple polynomial. So we let u equal ln x, dv equals 1 dx. So du equals 1 over x dx, and v equals x. Our formula is uv minus the integral of v du, which gives us ln x times x minus the integral of x times 1 over x dx. The x's cancel, so we have x ln x minus the integral of 1 dx, or x ln x minus x plus c. The general formula that we memorize is the integral of ln u du equals u ln u minus u plus c. Another example, the integral of inverse sine x dx. Using LIPIT, we let u equal inverse sine x because inverse trig comes before polynomial. So dv is 1 dx, du is 1 over radical 1 minus x squared dx, and v equals x. We substitute into the formula uv minus the integral of v du to get inverse sine x times x minus the integral of x times 1 over radical 1 minus x squared dx, which we rewrite as x inverse sine x minus the integral of x over radical 1 minus x squared dx. We notice a function and a variation of its derivative, so we can use substitution to do the integration. Using substitution, we let u equal 1 minus x squared, du equals negative 2x dx, so negative 1/2 du equals x dx, and we have x dx in our integrand. Substituting, we get x inverse sine x plus 1/2 the integral of u to the negative 1/2 du. Raising the exponent by 1 and multiplying by the reciprocal, we get x inverse sine x plus u to the 1/2 plus c. Substituting back in for u gives us x inverse sine x plus radical 1 minus x squared plus c. You don't have to memorize this formula. It is not expected that you know this for the AP exam.